So we're looking at chapter 13, problem number 16, and it says this. You've been visiting a distant planet. Your measurements have determined that the planet's mass is twice that of Earth, but the free fall acceleration at the surface is only 1/4 as large. What is the planet's radius? Also, to get back to Earth, you need to escape the planet. What minimum speed does your rocket need to do this? So we'll start with a diagram. This distant planet we'll call planet X. And of course we have the Earth drawn as well to scale. So the radius of the Earth versus the radius of planet X. We'll make an educated guess that planet X is bigger. We also know that the mass of planet X is bigger. So the other piece of information they gave us is that the free fall acceleration at the surface of planet X is 1/4 as large as the free fall acceleration of the Earth. So let's write that down. We know in general the free fall acceleration at the surface of planet X is equal to the gravitational constant times the mass of planet X divided by the radius of planet X squared. Now we also have this relationship that the free fall acceleration at the surface of planet X is equal to 1/4 of the free fall acceleration at the surface of the Earth. So let's fill in the details. On the left-hand side of the equation, we have the expression for planet X. On the right-hand side of the equation, we have the expression for the Earth. So, we know we can relate the mass of planet X to the mass of the Earth. Let's plug that in. So the mass of planet X is twice the mass of the Earth. Twice the mass of the Earth. So now some things cancel. G's go away. The mass of the Earth is also on both sides. And so let's go ahead and solve. Just doing some algebra, we get the radius of planet X squared over 2 is equal to 4 times the radius of the Earth squared. Solving for the radius of planet X, it's going to be equal to the square root of 8 times the radius of the Earth. So now let's plug in. We know the radius of the Earth. 6.37 times 10 to the 8 meters. Now we get a radius for planet X of 1.8 times 10 to the 7 meters. So the radius of planet X is about 2.8 times the radius of Earth. So planet X has a bigger mass, but it also has a bigger radius. And that's why the acceleration of gravity at the surface of planet X is less than at the surface of the Earth. So we'll solve the second part of this problem, the escape velocity from the planet, in part 2.